dear students and audience. Myself Yogesh, Gaidani, faculty at Mechanical Engineering Department, KKWAG Polytechnic, Nasik. And today we are going to start with which topic, dear students? Loudly. So today we are going to start with knuckle joint, and this knuckle joint will be very helpful for diploma mechanical engineering, especially for third year mechanical students. Let's start with the knuckle joint. So before starting knuckle joint, as this is the design of machine element lecture, and I have studied or I have given you information related to knuckle joint. Before designing any component, you should know which are different components are there in that particular component. Okay, so knuckle joint is there. Knuckle joint consists of how many elements? 3 elements. Okay, these 3 elements. This is the diagram of knuckle joint. So we can see this is the front view of knuckle joint and this is the top view of knuckle joint. Okay, so here knuckle joint is specially consist of or mainly consist of how many elements? 3 elements. And 2 elements are the supportive elements. 2 elements कैसे हैं? Supportive elements. Okay, so let's see the elements. So this is the first element known as single eye. So this is the single eye. Got it? And same single eye is over here in 3D view. Single eye will look like this. This is the single eye. Single eye. Single eye in 2 dimension and single eye in 3 dimension. Means you will get to realize how exactly single eye will look like. So this is the single eye. So first element is what? Single eye. So this is second element now. Second element is double eye. This is the double eye, also known as full. Single eye, second double eye is also known as full. So this is the full. And third main element is knuckle pin. So this is the knuckle pin. Okay, so knuckle pin we can see like this in 3D dimension. Knuckle pin will look like this. This is the knuckle pin. And 2 important elements or 2 remaining elements that actually we use for supportive purpose, that is collar and locking pin. Okay, so this is the combination of all these elements known as knuckle joint. So let's start with its application. Knuckle joint is specially used to transmit the load. It is used to transmit the load, and it is only transmit the tensile load. कौन सा load transmit करते हैं? Tensile. Okay. And specially we are taking example of this knuckle joint. Suppose we are going to use this knuckle joint in between tractor and trolley. Suppose tractor is there, trolley is there. We have to connect the tractor and trolley. We can use this joint. Okay. So for connection of tractor and trolley, we are going to use this joint. So this is the application of knuckle joint. There are many applications of knuckle joint, but we are taking only one application. That is what? Practical application. That is what? Tractor and trolley. Got it? Yes. Very good. Okay, now let's see which are different dimensions of knuckle joint. First, you understand different components of knuckle joint. Second, application of knuckle joint. Now straightforward, different dimension related to knuckle joint. Means knuckle joint में कौन-कौन से dimensions है that you should know, that student should know, or moreover that a designer engineer should know. So come here. See here. First dimension, first very important dimension is what? D. D is what? Outside diameter of rod. This is the outside diameter of rod. See here. This is in 3D diagram. D is the outside diameter of rod. Second is D1. Second is what? D1. So D1, dear students, D1 is equal to what? D1 is equal to what? Diameter of knuckle pin. Very good. Diameter of knuckle pin. Okay, diameter of knuckle pin. This is the diameter of knuckle pin. We can see here diameter of knuckle pin. But at the same time, diameter of knuckle pin will be equal to what? Inside diameter of single eye and outside diameter of double eye. So inside diameter of single eye and double eye will be equal to diameter of outside diameter of what? Knuckle pin. Okay. So D1 is equal to diameter of knuckle pin. Then D2. See here, D2 is there. So D2 is what? D2 is equal to outside diameter. This is the outside diameter of single or double eye. See here, outside diameter of single eye. At the same time, outside diameter of double eye. So D2 is equal to outside diameter of single or double eye. Then D3 is there. D3 we can see over here. in the top view. Okay, so D3 will be equal to, see here, D3 is equal to what? Here pin is there, pin head is there, and collar is there. So outside diameter of collar, or we can say what? Outside diameter of pin head. Pin head का जो outside diameter है, it will be equal to what? D3. It will be equal to what? D3. Okay.
Yes.
Then after this, we are switching over to T. Thicknesses are there. Different thicknesses are there. First thickness is what? Thickness of single eye. So here is the thickness of single eye. This is the thickness of
Single eye.
Similarly, double eye is there. So T1 is equal to what? Thickness of double eye. Thickness of double eye means here we can see T1 is equal to thickness of double eye. T1 is equal to thickness of double eye. T1 is equal to thickness of double eye. And finally T2 is equal to what? Thickness of the pin head. Thickness of what? Pin head or thickness of collar. Okay. So these are the dimensions, all dimensions which are importantly related with the knuckle joint, that everybody should know. What do you mean by D? What do you mean by D1? What do you mean by D2? What do you mean by D3? What do you mean by T, D1, T2? Everything you should know. Okay? Now let's start with different some notations are there which are related to load and which are related to stresses. So here W, or we can say W, here W, or we can write P. W or P is the notation for load. In some textbook there is a W, in some textbook there is a P. But W and P is what? Load. Very good. Then sigma T, sigma C. Sigma T is there. Sigma T is related to tension, tensile stress. Sigma C is equal to what? Compression stress. Then sigma B is equal to bending stress, and tau is equal to what? Stress. Now each and everything is known. Application, component, dimension, each and everything is there. Now straightforward we can go to the design. So let's start with the design, actual design. How we can design the knuckle joint. Okay?
Yes,
You all are ready?
Yes, sir.
Okay, let's start with the design. Let's start with the step number 1. While designing, I have already told you, while designing the component, designer has to think from failure point of view. Which point of view?
Failure point of view.
Is a component is going to fail. That we have to consider, that we have to imagine. So let's start with, as this both rods are directly connected to the applications. These are directly connected to what? Applications. Means as we are considering tractor and trolley, here is the tractor, this fork end is connected to the tractor and this eye end is connected to the trolley. So load is directly connected with these two components. So considering, as this is the smaller diameter, so initially due to loading, what happened? Due to loading, what happened? Chances of failure of the rod, and it will be in the tension, means this rod may get break. Suppose due to loading, what happens? This rod may get break like this. This is the breakage of the rod. This will going to break like this. This is the tensile failure. So here we can show like this, that as this is the diameter of rod and due to heavy load, this will going to break like this. Chances of breakage is there. So this is what? This is the failure area in 3D, in 2D. Okay. So considering this failure, considering tensile failure of rods. Okay. We are going to consider which failure of the rod? Tensile failure. So here we have seen this. So any type of stress, that is sigma T. Here tensile stress is going to develop. So sigma T is equal to what? Load per unit area. P divided by area. Here we know, as this is the circular one, so area will be what? This will be the area. This is the circular section. So who will tell me what is this area? This is the D1. So how much will be the area? Pi by 4 into D square. As it's a circular bar, area will be what?
Pi by 4 into D square.
Very good. So here I can write sigma t is equal to what? P divided by area, and area will be pi by 4 into d square. Okay? This is the step number 1. This is what? Step number 1. Here we are going to consider, we have already value of stresses, we have already value of design load. What is unknown? What is unknown? Diameter is unknown. Here diameter is unknown, and we are going to find diameter of rod. Means this diameter will be unknown for that particular type of load, and by considering the load, we are going to get what? Diameter of rod. In step number 1, which dimension we get? Diameter of rod. Speak loudly. Which dimension we are going to get?
Diameter of rod.
Here we get diameter of rod. So step number 1 over. We consider failure of the rod in the tension. By considering tensile failure, we have this value of diameter d. Okay. Then step number 2. Step number 2 is very important one. This is the empirical relation. Now, what do you mean by empirical relation? Here in the knuckle joint, if you get, step number 2 is very important. If you get value of diameter, we can find out each and every dimension of knuckle joint. We are going to get each and every dimension of knuckle joint as there is empirical relation. Empirical relation means what? If d is known, the rest of the value will be known. If we know, अगर हमको एक चीज का पता चलता है, that is what? Diameter. We get diameter, na? Then rest of the dimensions means given. See here. Come here. Step number 2, which is very important one, and step number 2 is empirical relation. What do you mean by empirical relation? Here, if we get value of diameter d in step number 1, then see here carefully. D1 is what? Diameter of knuckle pin. So diameter of empirical relation is says that if diameter d is known, diameter d1 will be equal to d. Means pin का diameter भी अब हमें पता चला है. क्या है वो? Diameter. Okay, diameter of rod. It will be equal to diameter of rod. Now we have d1 also. We have d also. We have d1 also. Then what about d2? d2 is what? 2d. Means just 2 multiplied by d. We get value of 2d. d2. Okay. Then value of d3. Okay. d3 is equal to what? 1.5 times d. Then t is equal to what? T is thickness of single eye. It will be equal to what? 1.95 times d. Then t1 is equal to 0.75. Then t2 will be equal to 0.5 d. Means from step number 1 we get value of d, and from value of d we get rest of the dimension, all dimensions. Now we have all dimensions related to what? Knuckle joint. All dimensions are there. Okay. Some more dimensions are there. When you see from the top view here, length from center point to this distance will be there. This distance is there, and this distance is equal to what? 4.5 times d. Very good. Then from at right side, from center to this point, this distance is equal to what? 4 times d. See here. Then curvature is there. This gap is there. Up to here is what? Single eye. Here is the foregain. Gap is there. So this gap we can find out by using which relation? 0.6 times d. Then this curvature is provided. So this curvature from this center to this distance is equal to what? 1.2 times d. Then this dimension will be equal to what? 1.2 times d. In this way, after getting the value of d, we have all values of what? All values of knuckle joint. Okay. So step number 2 is related to empirical relation. So step number 2 over. Okay. Now we switching over to step number 3. Now here onward, from step number 3 onward, just we have to check the all dimensions whether these are correct or not. अगर हमें एक dimension का पता चला है, बराबर? By considering failure of rest of the component, we have to consider all failure. Rest of the part के failure हमें क्या करने हैं? Consider करने हैं, and then we have to check. Then we have to check what? कि whether dimensions are correct or not. So it's a checking step. Which step? Checking step. So step number 3, here we can see checking of single eye. Checking of single eye. Single eye. Checking of what? Single eye. So checking of single eye first we have to consider single eye is going to fail in the tension. Well, checking of single eye in tension. Checking of single eye in what? Tension. Okay. So checking of single eye in tension. So considering here as single eye is there, so there may be chances of failure of single eye in tension. Means single eye may get failed in the tension like this. Okay. See here how failure will going to occur. See, consider. This is the single eye. So who will tell me how failure will going to occur? This is what? Very good. This is the tensile failure. Barabar? Means single eye will fail in the tension that we are going to assume. Okay, going to pass this dimension is equal to what? D1. Here this dimension will be equal to what? T. And this is what? Outside diameter, that is what? D2. D2. This is the D2. Okay, this is the 2D diagram. This is what? 2D diagram. And which failure is there? Tensile failure. So considering tensile failure, sigma T is equal to, here I am going to write sigma T is equal to what? Load per unit area. Here the cutting portion, capital D2 minus D1 multiplied by what? TD. Okay, it's a rectangular one. So, sorry, not it's a small D2 minus small D1 multiplied by what? TD. So, by using this equation, now we have value of W, we have value of D2, D1, T. With the help of all these dimensions, we can find out what? Sigma T. And sigma T we have to compare sigma T calculated with the given. Means after calculation we have हमें कौन सी value मिलेगी? Sigma T मिलेगी. But in the problem we have value of what? Sigma T. If sigma T is 70, if in the given data value of sigma T कितनी है? 70. And after calculation by putting all the values, what we get value of sigma T कितनी है? Suppose 50. कितनी है? 50. गिवन कितनी है? 70. और यहाँ पे आफ्टर कैलकुलेशन सपोज फॉर एग्जांपल वी आर गेटिंग व्हाट? 50. 50 यानी कि लेस है? कम है ना? Yes. So we can consider our design is safe. What we can say? Design is safe. And if this value is greater than given value, then we can analyze this is not suitable at all. This is unsafe. It will going to break. Okay? So here we are going to check. Here you understand step number 3rd? Yes. Okay, now step number 4. Step number 4 is very important by self failure. Now same we are sticking with same component, that is what? Single eye. We are going to stick with the same component single eye, but considering which failure? Crushing failure. Which failure? Crushing failure. Just imagine the single eye to the single eye. Here this pin is there. Pin is going to pass from single eye and double eye. Suppose pin is going to pass from this portion. Imagine pin is going to pass like this. Pin is going to pass now. Pin is passing from what? Single eye. And during as tractor is moving in the forward direction, what happen if driver has to implement the brake suddenly? What happen? Tensile load will convert into the very good. And at the same moment, what happen? Outside portion of this outside portion of what? Knuckle pin, which is in contact with the single eye's inner portion. Inner portion. This inner portion will be in the what? Compression, crushing. Means this portion will going to crush. Means crushing failure will be there. Here, see. This portion is going to crush. This portion is going to crush. And this portion is in contact with what? Knuckle. Okay. And actually this area is known as, technically this area is known as projected area. Which area? Projected area. So this is the failure area known as projected area. But by seeing from the front view, we can see this is the area. This will be the area. एक्चुअली कैसा वो कर्वेचर दिख रहा है ना, बट बाय सीइंग फ्रॉम द फ्रंट डायरेक्शन इट विल लुक लाइक व्हाट, रेक्टेंगल. सो दिस विल बी इक्वल टू व्हाट, will tell me, this will equal to what, thickness, and it t, and this will be equal to what, d1. D1 means diameter of knuckle pin. So this is the area of what, failure. Area of failure means by considering crushing failure, so sigma c is equal to what, w divided by area, and area is equal to what, d1 into what, t. So this is the crushing failure that we have going to consider, crushing failure. Okay, so by using all the value of, w, d1, dt, w, d1 and t, we have value of what,
Sigma c.
which value,
Sigma c.
Again we have given value of sigma c, here calculated value of sigma c. So calculated value should be less than given value, then design will be a safe design, perfect design. Okay, step number 5, it is again very important one, which is related to single eye. First we consider tensile failure of single eye, then crushing inside portion, crushing failure of single eye, then there may be chances of failure of single eye in the shear area. Means when there will be a up and down motion, due to this what happen, this single eye may get shear off like this. Suppose this is moving in the downward direction, this is moving in the upward direction, so shearing will going to happen over here. This will going to shear like this. So after failure this will look like this. Here is the d1, this is the t. So again area will be, shear stress is responsible, w divided by, who will tell me what is the area? What is area? d1. This is the d1. Actually this is d2. d2 minus what? d1 into t. So d2 minus d1 multiplied by t. So again we have all values, w, d2, d1 and t. Only unknown is what? Tau. That we calculate and we check with the given value. Here hence we can find out, or we can check the single eye in shear. Now let's move towards the second component, which is very similar, means failure of double eye, or considering the failure of double eye, it is very similar to what, single eye. So step number 6 is what, checking of double eye in tension. See here we have 3D value, this is we have 3D diagram of single eye, this is the double eye. So double eye may get failed in the shearing, tensile failure. So here it may get failed, here it may get failed. So like this, suppose this is the tensile failure. Which failure? Tensile failure. It will going to fail like this. Here there will be a breakage, and here again there will be a breakage. This is what? Tensile breakage. This is which breakage? Tensile. Means both rods are going to, both eye will going to fail like this. And if you see front view of this failure, it's like this. Here again, this is the outside dimension. Outside dimension is equal to what? D2. D2. Inside dimension is equal to what? D1. D1. Okay. And this is what? Thickness. Here is the thicknesses. Now thickness of, here we have to consider thickness of what? T1. Double eye. Thickness of what? Double eye. So this is T1. Again this is T1. D2. D1. D2. And this is the twice. This is happening twice. Okay. So considering which failure? Tensile failure of double eye. W divided by twice the area. This area is what? Double, na? So twice the area. So who will tell me what is the area? W divided by what? 2 multiplied by what? D2 minus D1 into D2 minus D1 multiplied by what? D1. Okay. Again, with the help of this failure, we have value of W, we we have value of D2, D1 and T1. We can check value of what? Sigma D. Now, step number 7. Here we consider tensile failure of double I. Here we consider what? Which failure? Tensile failure of double I. Now we have to consider which failure? Crushing failure. We already imagine crushing failure of single I, and double I's crushing failure will be very similar to single I. And same pin is passing through what? This double I. So inside portion of double I and outside portion of what? Inside portion of double I and outside portion of knuckle pin. Both are in contact with each other, and during breaking condition there will be a chances of what? Compression. So here we can clearly see checking of. In this way, this is the failure diagram of double I in the crushing. So the area will be sigma c is equal to W divided by twice the area, as this is the first area, this is the second area. First, second, so it will be a twice the area. So crushing stress is responsible W divided by twice the area. So area will be equal to sigma c W divided by twice. See here, this is what? D1 multiplied by what? T1. This is happening 2 times. So D1 into T1, twice D1 into T1. In this way, we get this value. With the help of all this value, we have value of crushing stress, and that crushing stress we can check with the given value. Okay. Double I also. So here this portion is there, means this portion of single I or this portion of pin will move over this side, and these 2 portions will move in this direction. Means equal and opposite forces are going to act on the knuckle pin. So obviously, which type of stress is going to develop? Which type of stress will going to develop? 2 type of stresses. Equal and opposite forces are going to act on the component in the tangential manner. Shear stress will going to develop. So see here, suppose what happened? This is the knuckle pin. See here, I am going to draw the failure. Okay, this portion will move along with what? Single I. And this portion, this both portion will move along with what? Double I. Suppose this is what? P. This will be P by 2. This will be what? P by 2. Here will be the failure. This will be equal to D1. Okay. So area, this will be the twice of area. And which type of failure is there? Double shear failure. So step number, I think step number 8. Failure of pin, knuckle pin in shear. Which shear? Double shear. Okay. So tau is equal to what? Tau is, that is P divided by twice pi by 4 what? D1 square. Pi by 4 into D1 square. Getting or not?
Yes, sir.
This is double failure of what? Knuckle pin. Means knuckle pin is going to fail in double shear like this. Okay. And in last, that is step number 9. If pin is not going to fail in the shear, we have designed it. Knuckle pin may get bent. So last step, bending failure of knuckle pin, and bending will be like this. If this is the knuckle pin, bending will be like this. This is the bending of knuckle pin. Bending. This is what? Bending. So what is bending equation? Sigma b is equal to what? M by Z. M by Z. M is equal to bending moment and Z is equal to what? Section modulus. And how to find out section modulus? Pi by 32 into d raised to or dq. Pi by 32 into dq. Okay? What is or not? Dear student, in this way we complete this design of knuckle joint. I think everybody got the concept of design of knuckle joint. You got it or not? Yes, sir. So what will be the in the last? Like.